Welcome to the deep dive. Today we're really getting into the nuts and bolts of an industrial-grade manufacturing center.
Yeah, the source material describes a pretty high-spec 3D printer, or maybe more than just a printer.
Exactly. We want to unpack what makes it tick, what its capabilities really mean.
And looking at the features, it's clear this isn't like a desktop toy.
No way.
Mm.
Multiple tool heads, a big heated build plate
Yeah.
that immediately signals versatility, right?
Absolutely. And they talk about precision, speed, suggest some serious engineering behind it.
Okay, so let's dive in. What about the core mechanics?
Right, so it uses three-phase stepper motors, and critically, they have closed-loop encoder feedback on all axes.
Closed loop. Okay, so it's not just sending a command, it's actually checking the position.
Exactly. It gets feedback. Think of it like it's constantly confirming, am I where I'm supposed to be?
Ah, gotcha. Which means better accuracy, more reliable.
Precisely. Highly repeatable, very precise positioning. Plus, they mention it leads to quieter operation and eye torque.
And speed. I saw some numbers mentioned.
Yeah, pretty quick. They claim over 80 millimeters per second for printing
80. Wow.
and over 160 millimeters per second for seek speed. That's when it's moving between print areas.
Okay, so fast and accurate thanks to that closed loop system. That makes sense for, industrial demands.
Definitely. Time is money in that context.
Now, this multi-tool thing sounds really interesting. A 5-position yoke. It holds 5 tools.
Yeah, a yoke. Basically, think of it as a holder, maybe like a carousel, that can quickly switch between up to 5 different tool heads.
Without someone having to manually swap them out.
Correct. That's the key benefit. It keeps the process running.
And what kind of tools are we talking about?
The list is pretty diverse. Standard filament extrusion, obviously, but also things like clay, biogel.
Biogel? Really?
Yeah, and even a spindle for light machining, maybe a laser, or a system for mixing resins.
Okay, hold on. A laser and biogel and filament on the same machine.
That's what the description implies. The potential there is huge for complex multi-material objects, or even integrating different processes.
You could print a part and then maybe laser etch it all in one go.
Potentially, yes. Or combine rigid parts with flexible ones. It really opens things up.
Let's talk about the build platform. It's big, right?
600 by 400 millimeters, and it's made of 10 kilograms of aluminum.
10 kilos. Why aluminum and why so heavy?
Aluminum gives you great heat distribution. It needs to be uniformly hot, up to 110 degrees C standard, or optionally 200 degrees C.
Okay, uniform heating is key for quality.
Especially for large parts or tricky materials, the mass helps with stability and thermal consistency too.
And it mentioned the platform is on a workbed that can hold other things, like vices.
Right. Vice's metrology tools.
Mm.
It signals that this machine is meant to fit into a larger workflow.
So you could print something, clamp it right there, maybe measure it or do some other light work on it.
That seems to be the idea, integration into a professional environment.
And it's built sturdy. Something about ball screws?
Yeah, 4 precision ball screws for the Z-axis, the vertical movement. They say it can handle bills weighing up to 20 kilograms.
20 kilos. That's a substantial object. Speaks to the overall robustness.
Definitely built to last and handle demanding jobs without losing precision.
One last thing, environmental control. An enclosed chamber that heats up.
Yep, up to 55 degrees Celsius inside the enclosure.
Why is that important?
Controlling the ambient temperature helps manage how materials cool down. It prevents warping, improves layer adhesion, boosts the strength of the final part,
Oh, okay.
and it lets you reliably use more advanced engineering materials that need those stable, warm conditions.
Right. Makes sense. Okay, so pulling all this together, what's the big picture here?
I think the key takeaway is the combination. You've got the precision from the closed-loop system, the sheer versatility from the multiple tools and materials.
Plus the robust build platform, the heating, the size.
Exactly. And the environmental control. It's a package designed for reliable, complex fabrication. Not just printing, but fabrication.
It really is more like a compact manufacturing center than just a 3D printer.
That's a good way to put it.
So the final thought for you listening, consider what having all these capabilities, printing different materials, maybe light machining, lasers all in one box enables. What kind of entirely new products or research possibilities does that create? How might it change the way we think about making customized things or even small-scale manufacturing? Definitely something to mull over.